Alright guys, so today we're gonna go over this linear functions review here. For now, we're gonna skip number 1. So, number 2, determine whether each table of values represents a linear function. For those that represent linear functions, write the function. For those that don't, explain why not. So, the best way to go about this is to see if there's a pattern. So, let's look at this first one here. This is it's increasing by 1, right? Every time by 1. So let's check the pattern here. From 9 to 7, it's decreasing by 7. This is decreasing by 5. This is decreasing by -3. So is that a linear function? Just by looking at it, I would have to say no. Even though you can see here, this is consistently 2 right there. I have to say no. Another way to check this problem, though, is to graph it in Desmos. So you can look this up in Desmos and just see if it forms a linear line. Quick little check. If I make this up, -4, say that's 9. -3, that would be 2. Oh, here it is. Sorry I didn't see it sooner. Look. -4. Look at this. -3 and -3. It's the same number. You cannot have -3 right here. It says -3 goes to 2. Okay. But -3 also goes to -3. You can't have -3 go to 2 different places at the same time. I didn't even see that. All right. So that means no. Not a function. Explain why not. -3. Actually, here's a better answer. Let me erase all this. Every x should go to only one y. Every input should have only one output. So that would be your answer here. Okay? So it's very important, to look at your inputs and outputs. Okay? Look at the second one. You're looking for your slope, M, and your y-intercept, B. Okay, we know slope is rise over run, which is the change in y over the change in x. Okay, so let's look at the change in y. From here to here is -6. -6 and -6. Okay, -6. The change in x from here to here is increasing by 2. +2, +2. Okay? So -6 over 2 is -3. Okay, that's our slope. Our y-intercept is basically when x is 0, what is y? It's 4. So we write our function. F of x equals our slope, -3x plus 4. There we go. That cleans it up a lot better. All right, let's move on. Elena's paid a constant rate for each hour she works. The table shows the amount of money that Elena earned for various amounts of time that she worked. A, determine the average rate of change. Average rate of change right there. That's slope. For the problem situation, be sure to include a unit of measure. So this is the easiest way to do it. Again, we're going to check the changes. From here to here is 0.5 in terms of time, or 30 minutes. But it's 0.5 of an hour. It's half an hour. So what's the jump from here to here? 23 for $4.50. So for 30 minutes of work, or half an hour, she gets paid $4.50. So if we multiply this times 2, it'll give us 60 minutes, right? Which is 1 hour. 60 minutes, which is 1 hour. So we multiply this times 2, $9 an hour. Okay? So, average rate of change, she makes $9 an hour. Okay? Write a function that models the table of values to find your variable. Okay, again, we're going to go back to slope and y-intercept. We know our slope is our rate of change, which we already got in the previous problem. It's $9. Y-intercept. If she works 0 hours, she makes $0. Okay? And again, this is all based off of time being our x and amount earned being y. So if the general form is like y equals mx plus b, then we're just going to plug in y equals, a rate of change is 9. We got it right here. 9x. Again, she works 0 hours, she makes 0 money. You can leave it y equals 9x, or you can do y equals 9x plus 0. Whatever is going to make you feel more comfortable. Okay? Define your variables. I kind of did that there, but we'll do time, money. X is time, Y is money. If you wrote this here and here, nicer than what I did, I'll take that. Determine the amount of money Elena earns if she works 7.5 hours. So you could just count it if you wanted to. 5.5, 6.5, 7.5. You could do that. And if we added $9 every time, from here to here, it's plus 9. You do another one, plus 9. I don't know what that would be. 49.50. You do another one, plus 9. So that one would go there. This next one, 58.50. And then the last one, you add 9 if you wanted to. You go 67.50. You could do that. So my guess is the answer is going to be right here. If she works 7.5 hours, make $67.50. But an easier way is using function notation. F of x equals this right here. 9x plus 0. We want to know if she works 7.5 hours. 9 times 7.5. 67.50. There you go. Let's move on. Malik received a $300 gift card from his grandparents using it only to pay for his karate lessons, which cost $30 per month. Write a function that describes the dollar amount of money, D, on the card after T months. Okay, so money is here. And then T T months. Months is on the side. Write a function that describes the dollar amount of money D on the card after T months. All right, so we want something like eraser. D of T equals, what's the rate right now? $30 per month. $30 times T months. I want to say that's it. It has a maximum of $300. But I want to say this is it right here. Graph the function that you wrote in part A, label X and Y intercepts, explain the meaning of context. Okay, so there's really two functions here. There is D of T equals 30T. This is the karate lessons. Okay, and the other one we can just do, we'll do D of T again if you want. D of T equals 300. Because, and that's the card. That's the gift card. Okay? And they're different because this is karate lessons and this one is a gift card. Once the gift card is over, it's over. It's a flat $300. So eventually, the karate lessons will pass the amount of the gift card. Let's go ahead and graph them. So 300. How should we do this? 10, 20, 30. Nope, that won't work. We'll do quarters. 25, 50, 75, 100. Nope, still doesn't work. 50s. 250, 300. Okay, so this one will be blue. If we go here, not a good line, but basically at 300, it'll, there we go. At 300, that's the line, okay? And I'm going to go ahead and label that D of T equals 300. Now, this other one, and I'll, this orange color will be right here, 30T. So we'll do 1 month, 0. 1 month, 2 months, 3 months, 4 months, 5, 6, 7, 8, 9, 10 months. So in 2 months, in 1 month, it'll be 30. So let's say about right here. In 2 months, it'll be 60. So about right here. All right, I'm just going to focus here. 3 times 30 is 90. About right there. 4 is 120. 4 times 30, 5 times 30, 15. 6 times 3 is 18. You get the picture. So something like that. And this will be 30T. Okay. So that's the second one. Determine what dollar amount remains after 8 months. You could look at the picture here and say, well, at 8 months, around 240, 250 will be left over. But because our graph isn't accurately drawn to scale, it's a little harder. So I recommend you use the functions. So let's do d of t equals 30t, where t represents the months. They want to know after 8 months how much money is left. So d of 8 months is 30 times 8. D of 8 is 240. So after 8 months, 240 bucks is left. And again, our picture kind of shows it, but it's not drawn to scale. So it's kind of hard to tell what it would have been. Okay? Use the graph to determine when f of x equals 4. Oh, when f of x equals 4 and the value of f of 4. Use the graph to determine when f of x equals 4 and the value of f of 4. So, f of 4, we just do this. We look at on the x-axis. Oh, money eraser. There's 4. It's -2. See? So f of 4 is -2. F of x equals 4. The graph is 4. Use the graph to determine when f of x equals 4. Okay, so basically it's saying when you have a problem like that, f of x equals 4, it's saying what input would give us an answer, a y basically, of 4. So what x would give us 4? So let's look at our y's here. This is 4. So what x would give us 4? -4. So f of -4 would give us 4. So that's one part of the question. The other one was, what is the value of f of 4? So this one is saying here, is saying when you put an input of 4, when x is 4, what's y going to be? Well, we know y is going to be -2. We actually checked that one first. So you see the difference in questions? I'm going to just clarify a little bit more. F of x equals 4 and f of 4 equals what? Again, what those questions are asking is they're asking x is input, y is output. So what this one here is asking, what input, so what x would give us an answer of 4? And I said, again, so we started here, we found 4 on the y, and we just kind of backtracked. We found -4. On this one here, it's saying when your input is 4, we look at the graph, what will the output be? Well, we looked at our graph. When x is 4, right here, and again, we just followed the graph. We knew it was -2. So it's always following the graph, the picture. Okay? And we knew that was -2. Okay? So, kind of tricky, but that's basically what they're asking. What input? What output? Number 6, evaluate the functions f of x equals 0.08x plus 4.2. So these are pretty easy. All you got to do is plug them in. I'm not going to calculate them. I'll let you do that. But they're giving you an input. They give you a function, and they want you to plug it in. So if you had a graph, you could just kind of trace the graph. But we don't have that. So a couple of things you can do. 1. You can graph this. If you graph this function right here, and then find out when x is 12.6, find out what the graph is, find out what y is. And then y, you'll find out your answer. Same thing, same function. After you graph it, you find this x value right here, and then just follow the graph to give you what the y value is. Okay, that's one way. Another way is to plug it in. And it doesn't say what specifically they want you to do. Evaluate the functions. I guess I just plug it in. All right, easy. F of 12.6 equals 0.08 times, I'll change the color here, 12.6. And you know what? I'll change it here too. 12.6. Okay. So then what we do is we add 4.02. Hi, baby. 4.02. And you just evaluate this function here. So this times this, and then you add this. Okay? So that'll give you your answer there. And I'll help you set up the other one. You guys okay?
That was just Harry.
Oh. Okay, so for the next one, you go ahead and you write f of negative 1.09 equals 0.08 times, again, plug in this value right there, negative 1.09 plus 4.02. Okay? So again, multiply and then just add this number. And there's your answer. And when you write your answer, write f of whatever they give you equals your answer right here. Oh. Okay? So that's that. So the last two questions, I think. Yep. These are pretty easy. I'm going to actually draw a line and just do right number 8 right here. Write the equation of the line that is parallel to y equals negative 1/2 x minus 3 and passes through the point 5, 12. So we're given a line, y equals negative 1/2 x minus 3, and it has to pass through the point 5, 2. Okay, so that being said, we know they're parallel lines. That's crucial. Parallel lines. So let's just call line A. Okay, line A is this one right here, the one they gave us. But line B is going to go through this point. And parallel lines, when you have two lines that are parallel, they have the same what? Slope. So M here is going to be the same as this slope right here. Negative 1/2 x. All right? So all we got to do is, given this slope right here, given this point right here, is find the equation of line B. So let's do that. Let's do y minus y1 equals m x minus x1. And let's go ahead and just plug in, okay? So y minus y1, which is right here, is 2, equals our slope, which is negative 1/2, parentheses, x minus x1 is going to be 5. Okay? So let's clean it up. Y minus 2 equals, we distribute the 1/2 here and here. A negative 1/2 times x is negative 1/2 x. What's half of 5? Is 2.5, right? So if half of 5 is 2.5, we do plus, and you can change it into a decimal if you want. Sorry, 2.5. So now, let's go ahead and finish this off. Y minus 2, well, we need to move the 2 over. So the opposite of negative 2 is positive 2. And we add 2 over here. So now you have y equals negative 1/2 x. 2.5 plus 2 is 4.5. Okay? And now there's our line. So now our parallel lines. So we can do line A, line B. This is y equals negative 1/2 x plus 4.5. All I did was copy this line right here. And line A is the one they gave us up there, right here. So this is y equals negative 1/2 x minus 3. So if we look at it, we have the same slopes right there and right there, but they have different y-intercepts right there and right there. Okay? So those are parallel lines. It's a lot of work, but you guys have seen this before. This is number 8. So number 9. Write the equation of the line that is perpendicular to y equals 5x plus 1 and passes through the point 3, negative 1. Okay, so 5x plus 1, 5x plus 1, and number 9. Y equals 5x plus 1 passes through the point 3, comma, negative 1. Passes through 3, comma, negative 1. And these are perpendicular lines. Perpendicular lines. All right? So it's basically the same process. I'm going to go a little bit faster this time, okay? I know perpendicular lines have negative reciprocal slopes. So if line A has an equation of y equals 5x plus 1, so line B is going to be, what's this? The point is 3, comma, negative 1, and our slope, if our slope here is 5, the negative reciprocal of that would be, and this is 5 over 1, would be negative 1 over 5. So our new slope for line B is negative 1 over 5. And just like before, let's go ahead and find the equation. This is y minus y1 equals m, parentheses x minus x1. And let's plug in all of our values, okay? Y minus y1, which is negative 1. Be very careful with this because oftentimes students put y minus 1, but it's y minus negative 1, okay? Because it's right here. Slope is negative 1 over 5, 1/5. X minus 3. And I got the 3 right here, okay? So all I did was plug in. I did nothing fancy. Let's clean it up. Okay, I'll go right there. Negative and a negative is a positive. So y plus 1. I'm going to distribute this here and here. Negative 1 over 5x. Half of 3 is 1.5. In a fraction, that's 3 over 2. But we can switch to decimals. No big deal. Actually, it does look kind of messy, but for now, let's just do it. We'll do plus 1.5. And then we're going to go here. We're going to subtract 1 to both sides. So y equals negative 1 over 5x plus 0.5. This was kind of messy, so I'm just going to rewrite it. Y equals negative 1/5 x 0.5 in a fraction is just a half, 1 over 2. Plus 1 over 2. And there's our line. Okay, and let me rewrite it. Or copy it. Copy. Copy. Line B is going to be right. Where is it? Here it is. Paste. Okay. And there it is. So we look at our lines. Our slopes are negative reciprocals of each other. And the y-intercepts could be the same, could be different. That doesn't matter. It's 1 and a half here. And there we go. Those two lines are perpendicular. And there's all the work. And that's number 9. All right, so there's a lot of work here. I did skip some. The ones that I did skip, you will not be tested on. Hopefully this was helpful. And good luck. Sorry for the background noises, and I'll see you guys on the next one. Peace.